Well, I came last year and really enjoyed it. Really enjoyed the atmosphere and the quality of the talks is top notch. So yeah, I thought good idea to come back again. I brought the whole team this time, so 6 of us. We're in a bit of a transitional period at the moment. So I work for a financial services organisation. We're very financial services is, it's a very classically minded sort of industry, and I think there's a lot of people who are eager to see it transform, see things improve in terms of delivery and delivering value. We've got more savvy customers, more savvy management. Everyone's really getting on board with the idea of delivering value more quickly, and DevOps is clearly the way to do that. I really enjoyed seeing, what was his name, Scott, I think, from Google, seeing his presentation last year and this year, and seeing the sort of the changes that he's presented each time round. I enjoyed the security presentation from CyberArk as well. That was really interesting.
Okay, cool. So if you're a traditional infrastructure person, what does it mean now for serverless? That's me. I'm a Docker captain. I do a lot of stuff with Docker. Also, just recently, as you can see from the shirt, branched out into Kubernetes. Mostly I'm concerned around low-level container run times like Containerd and Cry. Cry Containerd, actually. That's my son. He wants to be a computer engineer as well. You can get me at either that. He's actually 3 years old and is starting to want to look at code and already has finished his first version of a Lego game on Steam. So that's not a bad effort for a 3-year-old. In this talk, what we'll cover. So keeping up with ever-changing needs, basically we need to deploy faster. But what does that mean for the infrastructure space? Because, like we've heard, there's a lot of no-ops, right? So if infrastructure is seen as like a bad thing, that's probably not a good place to be, because like somewhere there is infrastructure. Like Shiva said, you've got to care about it somewhere. So let's have a look at that. So basically, look, I was like wondering how I'm going to explain it, and I was like, well, let's just look at what I did. And I've been across like 4 or 5 jobs doing this sort of stuff. And you can see where I come from and how I got there and the differences. I'm going to do an interesting observation because I am across the DevOps community and containers community. I dip my toe into the serverless community. There's a thought process that says like DevOps created and then containers was the evolution and then serverless. That is not true. They were actually made at the same time. So if you have a look at like DevOps and where Puppet come from, and the Borg project at Google was actually running in parallel by different people trying to solve different problems. So containers are not necessarily an evolution of DevOps. And there's some interesting things that come out about that. And then I'm going to look at how to tie this all together and have a look at like with what's happening in CNCF, put it all together and have a solution, a high-level solution for you to deploy heaps of new technology for CNCF in your own environment or on the cloud. So let's look at my journey. I started off as a junior Microsoft engineer. I used to change RAID drives, and I used to be called after hours, and I used to have a failed disk, and I'd go, I'm going to unplug this, I'm going to plug it back in and go, oh, is that going to sync and stuff? That's where I started my life. Now I'm a long way from there, and I work on Golang applications, on low-level stuff on the Linux kernel, and also building operating systems from scratch inside Puppet. So one thing about me, I don't work on Puppet server or the agent. I work in another division of Puppet that is looking at a whole heap of different stuff. So you're not going to hear anything about actual Puppet in this talk. I'm going to show you about a whole heap of stuff that we're working on in the R&D space that you could see actually come out in some of our products, like pipelines for containers, like how we can deploy Kubernetes and stuff securely and also efficiently for you, no matter if you want to run it in-house on like one of the hosted providers or if you want to run it on a cloud but have your own image. So what changed? What happened to me and how did I get into like where I am now? Basically, by the luck of something, I got sent to Singapore because I was a VMware guy to go set up AWS environment about 7 or 8 years ago. And it made sense to the manager who sent me. He knows VMware. AWS is virtualization, isn't it? We should send that guy, which is not the same thing. But this is when AWS just opened in Singapore, and some managers said that made sense. I basically got there and found out that I could provision a whole heap of nodes with CloudFormation, and I was like, holy moly, this is awesome, right? I can write code and do a whole heap of stuff. I'm like, if people find out about this, everyone's going to be doing it, right? This is awesome. And then I was like, oh, but I've hit my first roadblock. I've got a whole heap of servers there now, but they're not configured. I need to manually go in and then configure everything. And I was like, oh, I could write bash scripts, but that's not. Then I stumbled across Puppet. That's how I got into DevOps. And that's how I started to become a developer. So then from there, I was like, the DevOpsing tools has caused issues. I mean, even for Puppet, it would be naive of me to say that Puppet itself has got some flaws. We know that internally. We're working on fixing it every day. No system's perfect. So containers solved a whole heap of problems that configuration management left. But then containers created a whole new set of problems. So I got on containers fairly early. And then I just recently, through containers, I moved to serverless. I'm going to put it out there now. It's not one of the serverless models that the vendors, like Lambda or anything. It's actually an open source model that you run on top of Kubernetes. And I actually know the author of it, and it's actually been really good to use. This is, as I had said before, cloud, DevOps, containers, serverless is not a chronological. This is not chronological order. As I mentioned earlier, if you look at configuration management and what was happening in Puppet 8 years ago, and then look at what was happening in Google in the Borg project, they were running at the same time. They were running in parallel, and they were trying to fix two completely different problems. And I think the communities are still reflecting that, and I'll come up to my thoughts on that. The DevOps movement. Everything was about automation, right? Everything was like, hey, we can automate this. You can take your computer. You can install a whole heap of stuff. If it changes, we can change it back. I took the idea of configuring a cloud instance like bare metal, though. So it wasn't cloud native. We're still trying to work out how to make it cloud native, like Kubernetes is cloud native. Configuration management, it can configure cloud resources, but it's not cloud native. There's some limitations there. So that's a problem we've got to fix. And from looking at it, from taking bare metal to the cloud, there was problems that they were trying to solve, and I think they did a fairly good job of solving those problems, right? If you have EC2 instances and you want it configured, and then you want security audit, and you want to make sure that no one's logged in via SSH, and all these sort of things, solved, can do it, but there's limitations like every system. It's slow. It's not on, like I said, it's not cloud native. The barrier to entry is high. You've got to write a lot of code. I mean, even internally, there's a project that I've been founding to be able to auto-generate Puppet modules from Swagger definitions, because I don't want to write Puppet code all the time. Neither does people internally, right? We want to be fixing Puppet itself. And it's funny. It's written in Go. It takes Swagger definition, spits out a module in Ruby. The reason we wrote it in Go is because there was extensibility that we needed. We wanted to do concurrency and a few other things. But yeah, there's stuff in the DevOps world that we can make efficiencies on. This is the same in the container world and surely the serverless world. But they did solve a whole heap of problems that without that, a whole heap of people would still be in trouble and still be doing things manually. And yeah, but they did it. So for me, I was like, awesome. So I picked up Puppet. Puppet DSL didn't do exactly everything I wanted. That was awesome because they had an extensibility inside, and I picked up Ruby. So now I've gone from changing RAID configurations and Microsoft servers into building Ruby. And I ran with it. Ruby was awesome. It was really simple to pick up. It could do everything that I needed to do back then, but if you ask me today, there's some limitations there. But back then I was like, holy moly, this is awesome. Like, I can write stuff, I can write my own typing provider, I can do anything I need to do. Awesome. The side effect of this was I also moved to Linux, which is a massive step, which was totally fine for me because that's what I ran at home, and I loved it, and I naturally migrated towards it. But back when this happened, this was when like .NET apps were like prevalent. Like Linux systems were not, like enterprise wasn't thinking about running Linux. If they did, it was RHEL, and like you had satellite, and like it was like the startups and things where like the DevOps movement was coming from was like totally left field of where the enterprise was. So trying to get that sort of message across back then was super, super difficult, but a challenge that I loved. But this is what I mean. The DevOps movement created the following issues. It was a high barrier to entry. Even though there's things like Shep's got their things on their website where you can pull down, I don't know what it's called, but it's the version of Puppet Forge supermarket. Like people are writing stuff, there's a massive community around it. You can download it and use it, but it still was tedious to set up. Like you had to have something to install the server, installed that, had a list of what Puppet modules you needed, you had to install them. It's just a high barrier to market. The other thing was that you were actually putting a lot of trust in the community. As we saw this morning, that you can, like the Puppet server wasn't actually hacked. They passed malicious code through ActiveMQ. So that just proved that once you were on the server and you had root access, if you put something malicious in the module, it got passed around. So you had to have trust in the community. You should have like had some sort of validation about what you were pulling down and stuff. But again, the barrier to market is high. There's a lot of process around there. There's a lot of things to do. What it did do is let a lot of infrastructure people move a lot quicker, but it wasn't native to developers. So if you put like Puppet DSL or something to developers, they saw it as limited. They were used to writing proper functions. There was a whole heap of issues there. And that's still something we haven't solved and something that we're looking at. It's slow. Like to provision, like I take something that I wrote for PuppetConf last year is the Kubernetes module. It takes like 7 minutes to, like actually if you install it on the cloud with nothing, with like CloudFormation, install Puppet, and then it's like 13 minutes before Kubernetes is up with like 5 nodes. If you did that on Google right now and pressed, I just want to host a service, it's going to be about 4 to 5. So it's slower. There's pros and cons to that as well. And as I said, it's not cloud native. So what I mean by that is if you wanted to install something with Puppet on the cloud, you'd already need Puppet installed locally and do Puppet resource. And then, yeah, there's a whole heap of pulling dependencies and inner looping. You'll find that most customers that we speak to and most solutions is that they're using something else to bootstrap Puppet into a cloud and then Puppet configures from within. That is still not, from our point of view, cloud native. The container movement come along. It's easy to use. I'm going to put that in, and I'll come back to that. It was the developers centric, and it was cloud native. When I say it's easy to use, it's easy for a developer to take their code, wrap it in a container, and run that locally and say that should work in production. That's the easy bit, right? Getting that in a production state, having a workflow to make sure that that's secure, Kubernetes and some of the orchestrators, that's hard. I've worked on Kubernetes like for the last 8-9 months, like been knee deep in Kubernetes, and there's still stuff that surprises me about it. Like I had the gentleman that I work with, he goes, every time we work with something and we try to break or do something, it's a pageant, like we learn something new about Kubernetes. It's an awesome product. I love Kubernetes, but there's some limitations. Like the logging framework across all the different projects are not the same. So you have to do manipulation of logs externally to get it and then make it into a format that you can easily ingest. Things like that, developers aren't worried about that stuff, right? They're worried about, hey, I wrote a container, that container can be a pod, that can go out on the Kubernetes and everything's good, right? But what about all the other stuff behind it that like the operation or SRE teams were worried about? That bit is actually still hard. But for me, containers made perfect sense. The isolation of application was like heaps better than what I could do with configuration management. My first deep depths into the container was Java applications. So we had Java dependencies. We'd install 2 things on a server. One would install through CD, and it'd update a package, and now this one's broken because that package isn't compatible with that application. Having the Java runtime on the actual OS was like causing us issues. So we moved to containers. I personally never wanted to learn Java, but through working with containers and getting involved with Docker, I picked up Golang. And at the time, I was finding a lot of limitations with Ruby, which goes into like some of the security concerns around gem, validating gems, pulling in stuff. The place I worked was a government organization. So being able to vendor in, have that code statically analyzed and signed off in the source repository saved me a whole heap of issues. I mean, I could have made my own gem repository as well, but it's easier just to have it vendored in. And I found that writing binaries helped me be more secure in the container ecosystem by only using Scratch containers. If you don't know what Scratch containers are, definitely look it up. It is not an OS, it is just the runtime and your binary. That's all it is. But the container movement, although like if you speak to people that say, oh, like it fixes everything, Kubernetes is self-healing, there's a whole heap of stuff like that. How many people here know how to save Kubernetes if the rough consensus has gone AWOL in etcd? That's what I thought. It's not easy, right? And if that's your production system, if you're not doing backups of etcd and testing the resolve process, like I've had issues on GitHub where they've used the pub module to install, and they've gone off, installed one node, and I've installed 11, and the cluster doesn't come up. Well, you had consensus, and you lost consensus, and now you're in consensus flap. Just because like there's stuff out there to install it, you still should care what's under the hood, because if it breaks, unless there's automation around that, like you're using something like the etcd operator, you still need to know what's happening. And even if you use an etcd operator, you still need to know how that operator operates. So that kind of doesn't make sense, but yeah. Even the only way that you can get around this is you have to go for what Shiva was talking about, and it would be a serverless Kubernetes cluster where someone like Google will take that off your hands, and they'll say, hey, I'll take that as my concern for you. You only need to worry about how the Kube API is reacting, how you're deploying your things onto it, and then we'll handle etcd, we'll handle upgrades, we'll handle all this for you. And that's why, I mean, container orchestrations are hard. And anyone that's had a problem with the container orchestrator in production will tell you it was not easy to fix. And this stuff, like, the beautiful thing about Kubernetes is, and the simplicity of the architecture is, it self-heals everything on the top layer really, really well. So if you deploy an application on it and something goes wrong, like, it will restart it, it'll do a whole heap of stuff. It does it so well, but it can't monitor itself, and it can't self-heal itself. So if you're starting to see stuff like problems in etcd, that's when you're in trouble. The tooling for automation was limited. Like, even installing Kubernetes now, there's not a one way or multiple easy ways to use automation to install it. Finding the container images is always been limited as well. So, I mean, there was the people at Rocket that did like the Golang sort of way of defining what an image looked like. Docker's obviously got Docker files, which is just bash. The reason for that, though, is bash is easy, everyone knows it, but then the other side to that is bash is limited, you can't do everything. But I think you're going to find that changing very soon, because BuildKit's coming out, and BuildKit has pluggable front end. So you can actually, if you wanted to model, if like Puppet brought out a front end, you could model your Docker file in like Puppet code, and then that would spit out an image that would not have a Puppet agent in it. It would just be modeling, speak to BuildKit over gRPC, spit out the image, and then that image would be like a standard Docker image. There's a whole heap of work going around BuildKit and different front ends and stuff like that. Chef could equally do that. Like community member could do, and you could model it in Python. But that's been open sourced, and so if you want to have a look at that project's really cool. Before I go on, this has been said today, I do not like the term serverless. It's a function as a service. There's always servers behind it. The reason I want to bring this up is because like when most people talk about serverless, they think Lambda. And that's where the majority of the people think. It's AWS. Google's also got one. Azure's got one. But you can run your own. So what happens if you've got security restrictions around you and you can't run Lambda because it's like not ISM compliant, say? What happens if you still want to have function as a service in your environment, but you can't use this? It's still there. It's still available to you. There's heaps of frameworks that you can use. So the reason we went with this is like we didn't want vendor lock-in. We wanted to be portable. And we also wanted to base it running on top of Kubernetes because we run a whole heap of other services on top of Kubernetes, so it made sense. So we went with OpenFast, which was something that came from Alex Ellis, that's a fellow Docker captain. VMware has just bought it, and it's in their incubation project. But what that allowed us to do was write serverless functions and be able to write it also, and we started using this a while back, when Lambda was only Node. No one in our team knew Node. We knew Ruby, we knew Go, C, but no JS stuff. So we were able to make a container, write it in Go, and have a function that was Go-centric. It made perfect sense for us to go down this path. And that might make sense for your business as well. You might not have JS guys, but you want some sort of function as a service functionality. I know that like Lambda's come out with a whole heap of new ones now, but at the time, like we tested out Apex where we were writing Go and it was shimming to Node, and I was like, it doesn't sound right. Like if you went back to me 10 years ago and go write in this language and then we'll convert it to this language and we'll execute something, I'd be like, huh? Why didn't you just write it in the first language in the first place? So I understand why the project came around, but I still, like morally, couldn't get my head wrapped around why I would write in one language into another. But anyway, this is why Alex created OpenFast, and it works perfectly on top of Kubernetes. The FAS movement is super easy to use. It's aimed at developers. One of their things is there's no infrastructure. But as we've seen from other talks today, there is still stuff you need to care about from an operational point of view. But it's really super easy to get up and running, like write a function, have an API gateway and stuff. I put this slide up here because like I don't know anyone that's used function as a service in anger enough to know all the issues with it at the moment. I mean, Shiva brought up a whole heap of cool ones that like I hadn't used Lambda like in anger like that to see like the difference with Kinesis and SNS and stuff. So there's stuff starting to come out, but I think that we'll start to see this fill out a little bit more. And kind of like when containers come about, like there was a whole heap of issues around tooling and things like that. DevOps, containers, and serverless. Let's talk about these from a community point of view. Firstly, these are not Puppet's views, these are my views. Traveling around and speaking to people at different conferences internationally and locally. If you think any differently, please let me know in the questions and like be more than happy to talk to you about it. These are completely separate communities. There's very few people that I can name off the top of my head that is across DevOps and across the container community. The most famous person probably was Kelsey Hightower. He used to work for Puppet, and then when he went to Google. But he is very, very container-centric at the moment, going in more to serverless. So he's not even like going backwards and saying, like back into the DevOps community. He's full force ahead, containers and that. There's myself that's across two. Gareth Rushgrove was at Puppet, now he's at Docker, so there's another one. But there's very few people that are across both. And if you look at the founding leaders there, these people weren't talking to each other when they built their project. Like like Google was using Puppet at the time when Borg was coming around. So it wasn't like the two ideas were like totally separate. But the people who were thinking about the issues were trying to solve two completely different problems. And what is that cause? It's actually caused silos, right? So we get up here and we talk about how like we should split down dev and we should ops and put them together and we'll all work together and everything will be happy, right? Unicorns will come out, birds are chirping, all of my business problems are solved. But yet in the community, like vendors are going and siloing themselves and saying, oh, we don't play with this or we don't play with that. So, but that actually boils down to affecting people's business, because there is solutions out there that can be solved. One community could have solved it and the other community can learn from it. They might not have the perfect solution in one community, but they'll have a framework or an idea that can be morphed into something for the other community. Let's run through a real-world use case of this. How many people are on any of the Kubernetes SIGs? I probably thought that was the case because I get up at 2 a.m. to listen to them. So if you are on SIG application, people will talk about Helm, how good it is and how they like it and stuff. But the one complaint about Helm is that they've got a YAML file for an environment variables, and how do they use that across multiple environments? And I'm like, what? Like, DevOps people have been doing this for ages, right? I'm sure, I don't know what it is in Chef they've got to do environment interpolation, but I'm sure you've got something. Environments, yeah. We've got Hira. I mean, either or of these might not be the perfect solution for Helm, but there is precedence there to say someone's thought about this. And the container community are not speaking to the DevOps community. And this was so prevalent to me because I was doing a lot of container conferences, and I was at PuppetConf, and I did a birds of a feather of containers. And the kind of questions I was being asked, I was like, this has been solved, you know that, right? And they're like, what? Like things like, how do you securely deploy a container? I was like, well, you know there's Notary and stuff, and they were like, no. I was like, and it was because they were so focused on like the DevOps tooling, they hadn't looked out to see what the container ecosystem was doing. They actually were trying to fit a DevOps tool to deploy a container application and like trying to like hack that to make it work. What I'm trying to show you here is like, don't be blindsided by technology. Go out to all these communities and talk. You as developers are building business applications for your business. You could be the person that fixes this issue. Why can't you be the one that puts a PR against Helm and says, hey, I've got an idea? Maybe it'll get through, maybe it won't, but like any one person in this room could do that. So don't limit yourself to like what the community is doing. Look across all communities. And then that will give your business a better outcome, because don't just be siloed like the vendors are. I'm from a vendor and we're bad at it. Have a look at what you can get from all the different communities and see what different people are doing. As I said, like all these are open source. Everyone will at least look at a PR that's sensible that go up there. So yeah, why couldn't a person in this room solve this inside Helm? Like they totally could. So let's tie all these new things together to make your business succeed. And we're just going to use CNCF, right? There's all your tools there. It's super easy. Let's build an app. Yeah. How do you, like, if you're looking at new technology, how do you even know where to start? And I'm going to focus this on a very simple application. The only assumption I have is I want to run containers and serverless on images that I control. So I've got security concerns that I can't use like a hosted service. It can be on the cloud, but it has to be on site, maybe EC2, because like they're ISM certified. So I need some sort of control. We could be running a government application. We have to be concerned with security, but also usability of the application. I would start, the first commodity that is going to give you a headache is the OS. OSs are onerous. I think that OSs are on their way out. There's better ways to do things, and I think Linux Kit is number one. If you only want to run Kubernetes, why wouldn't you run an OS that's only got a Linux kernel, containerd, and a Kubernetes and a runtime for containers? No SSH, no other things, glibc. All this stuff's in a scratch container, and it works, right? Why are you patching and doing all this maintenance on all the other stuff in the OS that you don't need? Does that make sense? Like, when you think about it, you're like, oh, wait a second, it doesn't. So if you only want to run containers and you're going to run stuff on top of Kubernetes, why not build your own OS? Now, you're going to think, like, that's crazy, right? That's super hard to do. It's there already on GitHub for you. You can literally build Kubernetes OS. The work's being done for you. Who here is using Docker for Mac or Docker for Windows with Kubernetes in it? Only one person. Oh, two. Oh, I thought that would have been higher. That is actually Linux Kit. The whole Docker for Mac project is running Linux Kit underneath the hood. It gives you a lean OS. It gives you a kernel. You can actually build your own kernel, right? So there's a 4.9 kernel out. There's a 4.14 kernel out in alpha you can use. You can plug and play whatever you want. You can build your own OS. And this becomes super powerful, right? So, for example, what we could do, one of the projects we've got in R&D at the moment is I can build Kubernetes, I can attach an EBS volume, and that is where the customer information is, and I can replace the Kubernetes cluster at will with Linux Kit images. So I can update the cluster. The only limitations, obviously, is like things like RAF consensus and a few other things. But I can do that on the fly. The customer data is in the EBS volume. I can track that, and I can replace that and reattach it to the new instance. This is super powerful, right? Because like when any of the vulnerabilities come out, I can just replace it. Keep the customer data, replace the rest. Just throw it away. I don't have SSH. I don't have a whole heap of things to patch. If I find out that there's a vulnerability in one of the containers, that's fine. Create a new image, push it out, replace, and do the upgrade. So I talked about that. I was scared putting this in because Red Hat just bought CoreOS. And this is a CoreOS project, so who knows where that's at now. Sorry if there's anyone from Red Hat. I do love you guys. Yeah, because I think they've already discontinued like CoreOS's core application, CoreOS's container Linux, and it's atomic now. But yeah, this was really cool. You could bolt this into a pipeline. You could scan your images to make sure there's no vulnerabilities in them, which allows you to add security up front, because I said as one of the assumptions, we want to be secure. So with Linux Kit, we have smaller attack vector. We're also going to use kernel namespacing and setcomp to protect Unix sockets. So we're secure all the way through the kernel. And you can do that easily with Linux Kit. It's just in the YAML file. You just put different things in different namespaces. The containers will think they're running as root. They're actually not, because setcomp underneath won't allow it to. And then like the attack vector is super, super small. Like I know for a fact I can ship an ISO with running Kubernetes on it with cry container D, and it's 700 megs. And it'll fire up in about 12 seconds. That's pretty good. But back to Claire. Claire will allow you to scan your CVE data to make sure that there's nothing in there. If you're already using Scratch, though, then you shouldn't worry about OS patches, because it's Scratch. There's nothing in there except your binary in bin. But if you're using some sort of language like Python, obviously you can't run Python from scratch. It won't work. So you need Alpine. As we've seen in many other talks, there's vulnerabilities in the Alpine containers on Docker Hub. But what this allows you is to give the security team the right or the information to be able to say, yes, deploy it we'll take on the risk of this vulnerability being in the container, or no, this is a high, we can't do it, you need to wait till there's remediation. But you have an audit trail. That's what security is all about, right? It's about risk management. It's not about them saying yes or no. And it's hard for them to say yes if you haven't given them the information about what they're saying yes to. So their default answer then would be no, because they don't have all the information. Claire will allow you to get that information, collate it, and if it's something that's already out there, there's a CVE that's already there and patched, you can then show remediation by running the build job again and having that go through, be green, no CVEs, and then if you take your Jenkins log, pass that to whatever logging framework you want, there's your remediation documentation. And you've got process to show that you've done patching. That's where you should be doing your patching, not in the wild. You should be doing it before it's deployed. It makes perfect sense now. If your unit of application is small enough, or you'll build your own OS, you can do this with Linux Kit, right? Because all of Linux Kit is containers. So you can actually scan each part of your OS before you construct the OS and sign it. Another thing we could do, so that's it there, just like Jenkins, Claire, image signing. The other thing you want to make sure is that your images are signed. You want to make sure that there's trust and no one's done anything to your images before they go in production. Docker donated Notary to the CNCF. It is now officially a CNCF product. And what that allows you to do is build a trust level between what you've built and what is running. If the crypto signing doesn't match, the container doesn't run. This is also built into the container D now. And this is what Linux Kit uses to make sure when you're constructing your OS, no one's put any malicious code in any containers that you don't know about. If you put the trust in your Notary and it's just a line in the YAML file and something in the crypto signing doesn't match, the OS won't build. It'll say it's from an untrusted source. So you can have full control over what's going into your OS, like down to the bare minimum that you need just to run Kubernetes. And then on top of that, we'll install OpenFaaS, and we'll use Helm to do so. That's straight from their GitHub. There's a Helm chart. You can just install it. It's going to run on top of Kubernetes, and then from there, we have got an automated way to roll out Kubernetes with a serverless functionality on top of any environment. So Linux Kit does AWS, Azure, VMware, OpenStack. It's literally a flag at the end of the build to say what images you want to port out. Quote, the automated stuff. The stuff that I missed out on here is there's a few other steps that you need. So in the Linux Kit image, like if I was going to do it, I'd have an application that was called like bootstrapping the cluster to change certificates and things like that. I would also replace, because Linux Kit is based on kubeadmin. Kubeadmin isn't HA out of the box. Once the cluster's up, I'd have the bootstrapping application also put in an etcd operator. So as more nodes come up as they would have HA across there. But that is just something, a container you can build. I would build it in Golang, just put in a Scratch container, and then you can orchestrate that through the Linux Kit build, which is super simple. This has been built and is in R&D at the moment. So it does work, and it is being tested. So other technologies used, because I love Go. All my messaging will be done over gRPC, which is, again, another CNCF project. And all my metrics and logs out of the Kubernetes cluster is coming from Prometheus. So there was no good me building a Linux Kit image if it ran like a three-legged dog. I had to get metrics out to see how the cluster was running, making sure it was performing. I tested it against performance on GKE and also on AWS to make sure that it was a valid image that could run smoothly across all environments. And it came out pretty good. And now, well, I've got 3 minutes left, but questions? Can you tell us more about the serverless platform you're using in Kubes? Yeah, so it's OpenFaaS. It's a function as a service. The architecture is as like a watchdog service. It does something. The watchdog service makes sure it comes back, and it just keeps firing off. One good thing about it is they've got a store. If you install it now, you can actually go get functions that other people have written. You can, yeah, it's really good. I can tell you more about the use case. The first real use case we did is we're actually using a GitHub bot that triages issues for us. So when someone says, oh, there's an issue, it loads a GitHub template. This goes through and makes sure that they filled out all the information, knows some like strings and data about what it is, triages it, and then it sends a message as the right person to have a look at it. That saved a whole heap of time for the team because like I used to get up with my coffee in the morning, go to GitHub issues, and that'd be the first 45 minutes of my day. This has already triaged it for me. I just come in and go, oh, yep, this is this. What are the disadvantages of running serverless on Kube in AWS? Is there anything like automatic? Yeah, so there's none of the, there's not, you would have to write those integrations. It's not there out of the box. What do I think about ECS? I have no thoughts on it. I haven't used it, and personally, if I was going to pick a vendor, I would go Google, Azure, AWS. That's my personal opinion, not Puppets either. But we do use GKE every day. It's like really good. I've been testing ACS, which is Azure. It's like works really well. Some of the work Jesse Frizzell's doing around ACS and non-root containers doing image build on Kubernetes is super cool, and that works on ACS at the moment. So yeah, I've been looking at that. I haven't used ECS, sorry. How can you store container images securely? Well, it doesn't matter where you actually store them. You could use JFrog, you could use anything. It's the crypto signing on the image layer, and then the trust from the engine or containerd back to the notary server. So you can pretty much store them wherever you want. It doesn't make any difference where you put it. Have you evaluated Influx data or other money? No, I haven't done Influx. I actually know someone that was working on that project, but I haven't looked at it. Is your HA project for Linux Kit going to be open source? I can't tell you that because I'm not the product owner. So watch this space. I'm an engineer. Do you get full end-to-end traceability when deploying using K8 and Prometheus? Yeah, there's pretty good. Where do I get that shirt? I actually got it from Weave, the guys at Weave, so Illy and stuff from Weave. So, do you get full end traceability deployment using K8? Now that's a bit of a loaded question. Do I get full traceability? Define full. Do I get traceability of all the Kubernetes components? Yes. Do I get traceability of the applications running on top of it? No. Not without running custom stuff. So if you have a look, Kubernetes has like an endpoint that you can point Prometheus out, to pull metrics out. That's built into Kubernetes. That's what I've been looking at. How scalable is OpenFast? The numbers of volume requests per second and served in production. I have not hit it. Well, that would all depend how much compute you got, the language you're using and stuff. Would you retract the statement from earlier in the talk that every Docker has known vulnerabilities? Reacts to the statement. Yeah, I would say that's. I mean, if you have a look at like some of the bigger like vulnerabilities, like glibc was massive for Docker, right? To patch glibc, like pretty much like every image that used Debian or any of the bigger ones was vulnerable at some point. I mean, all the information in Docker is easy to get. Like if you don't have Claire set up, you can actually go have a look at build, have a look at tags, and then click vulnerability. And all the information is there for you on Docker Hub. All right, time's up. Thank you very much for listening.